and explain two things about these kinds of questions, because what's asked of you is to draw some number lines, to graph your solutions on a number line, and then they provide you some information about what kinds of solutions they have. So I need to back up a little bit, and I need to talk about, and this is worth jotting down somewhere else in your book, the different kinds of families, or the classical way of saying it is the sets of numbers that we talk about in mathematics and how they differ from each other, okay? Because the language that you're looking at in the question directly follows from these different families of numbers, okay? So, to begin with, all numbers start with counting. Everywhere in the world, every culture that has devised numbers, which by the way is not all of them, have all started with counting. And we kind of have called these the natural numbers. Now, like I've said to you before, mathematicians, famously lazy, will write as little as they possibly can. So this n with a kind of funky little double line through it is the symbol for the natural numbers. You also hear them called the counting numbers because you count them, okay? So they're 1, 2, 3, 4, 5, 6, etc. off to infinity. Some people count 0 as a natural number, some people don't. I'll just put that to one side. After the natural numbers 1, 2, 3, 4, 5, 1, 2, 3, dot, 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 we then, in year 7, we extended that, not just from 1 point to positive infinity, but also in the other direction to negative infinity, right? So we said, actually, you can have numbers which have direction, and we call them integers. Okay? Now, the symbol for integers, frustratingly, is not I, it's actually a Z, again with the double line, which is a reference to all of the German mathematicians who contributed an enormous amount into this in the 18 and 1900s. Okay? I think it's German for Zahl, which has to do with counting numbers. Okay? So the integers rather, they extend from negative infinity, and then they pass 0, and they keep on going just like the natural numbers. Okay? Now, after you get the naturals and the integers, you get the rationals. Now, I don't have the time to deal with it now. There's a great story behind why they're called rationals and why we think of the word rational as like it makes sense, but it really is about the word ratio, right? Which explains why these are actually talking really about fractions. Aha, a third, 257 on 891. All of these are fractions. The symbol we use is a Q. Do you reckon you could guess it is a word in the English language that Q stands for that has to do with fractions? Anyone? Think. Yeah. Quotient. Quotient. Very good. Q for quotient. Okay. So these are all the fractions and so on. I'm not going to write all of them because there's too many. Now after that, you can divide this in a few different ways, but for your purposes, what you need is the real numbers. Okay. And that's this symbol I've already put up here. Again, it's an R. Thank goodness it actually stands for what it says, with a double line. In there you find all different kinds of numbers. In fact, pretty much every number you ever have to deal with is a real number. Square roots of weird things like surds, right? Transcendental numbers like pi and e, which you can't write even as a surd. All of them are in the real numbers. Now, there is an outside to this. We call them complex numbers, and that's a story for another day. Okay? Now, the most important part of this diagram for you are the integers and the reals, because they're the ones that appear most frequently in this question. So we need to be able to sit these apart. Okay? So these guys here and these guys here. Right? Let's answer these one at a time. If you get given a question, you simplify all of the algebra out, and this is your final line. They want you to graph all of the numbers, x is greater than 5, where x is a real number. Okay? Remember I said to you, the real numbers include all kinds of weird, wacky numbers, right? Like surds, like fractions, like pi, and so on. Okay? So if you put them on a number line, the first thing I want to point out is every number line should have the most important number on the entire thing, which is 0. You've got to have 0 there. Where is 5 going to be? You don't have to put every single marking, so long as it's to the right of 0, you're in the right spot. Now, to the right, you're going to start from 5, and to indicate that boundary, you need to put a big, fat, full circle there. Okay, it should be coloured in to indicate 5's part of your region. And then you can say, well, everything else on the right-hand side, they're all included. You can go as far as you like, all those numbers satisfy that inequality. Okay, couple of minor notes. Please see where my dot is, it's on the number line, it's not hovering. Look at where my arrow is, it's on the number line, it's not hovering. The reason why is because you've been drawing number lines a lot whenever you do a Cartesian plane, right? You've got an x-axis and then you've got a y-axis. On those axes, on that plane, up and down, it has meaning. It indicates there's a vertical value, there's something else. But there isn't anything like that here. That's why we're on the number line. All right, have a look at this one. X is less than 5. I'm going to draw the same number line with the same 2 points of reference. But this time, what family of numbers am I dealing with? Look carefully. These are the integers, right? So they're whole numbers. Can you see that? Some of them are negative, but they're all whole, right? So I want all of the whole numbers. I'm going to add one more thing here. Sometimes you get asked for positive whole numbers, positive integers. Sometimes you get asked for negative ones. So where are all of the positive integers that are less than 5? Can you name them? 1, 2, 3, and 4. That's it, right? Now, seeing as you can't do the numbers in between, right? Like for instance, if I've got 1, 2, 3, 4, 1.5 is not one of these integers. So you can't just color all the way through. What you must do is label it just like you've labeled this endpoint here. If this is 1, 2, 3, and 4, then you color each of those individually on the number line itself. Okay? You can't have any of those gaps because those gaps aren't these guys. Last one just before you run. Frequently you'll end up with something and you're between boundaries, right? So again, you put the most important number on the whole number line. This time, because I've got 2 numbers, it's important that your scale is at least somewhat consistent. If that's supposed to be a distance of 1, then 1, 2, 3, 4, 5, that ought to be a similar scale, okay? I'm between. This is a filled circle, but look at that boundary. Is -1 included? No, it's not because there's no little line there. So I'm going to put a hollow circle there, and then I'm going to join up everything in between. Okay?